Okay, where were we? How would you prepare a 1 liter solution of 2.5 molar KNO3? How many moles of KNO3 would you dissolve? Well, that's a molarity problem. So I have 2.5 molar equals, I have 1 liter, so I have X moles. So solving for X, 2.5 times 1 is 2.5, so we have X equals 2.5 moles. So the first part of this answer is 2.5 moles of KNO3. How much water will you add? Well, it's in the solution total volume is 1 liter. So what we do is we put our 2.5 moles of KNO3 in here. Blah, 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 blah. There's our 2.5 moles. And this is our 1 liter mark. And then we add the water until it reaches or add up to the 1 liter mark. How much water will you add? I will add up to the 1 liter mark. Now, what we can't do is say we're going to add 1 liter, because 1 liter is our total volume, and this stuff takes room. So we basically have to add up to the 1 liter mark after we've added our solute in there. Okay, how much NH4Cl will you need to make a 2 molar solution? Oh, well, number 6 we can't do, because molarity problem, we have 2 molar equals moles and liters, and we don't have either of these, do we? So we can't do this, can we? Nope. 6x. So we're not going to do that one. Now I could have made an amount up. I could have said 1 liter, and if I had made it up and said 1 liter, then it would have been 2 moles, obviously. Okay, 7. Colligative properties depend on the concentration of solute particles, but not type. What they're saying is it doesn't matter what kind of molecules they are, what type of molecules they are. It matters how many of them there are. We went over this in class, why. So I hope everybody caught that when we went through it, why concentration increases. Okay. The boiling point of water is 100 degrees. What would most likely happen to the boiling point if 15 grams of KCl was added to a beaker containing 500 grams of water? Okay, well, colligative properties tell us that if we add a solute, it depends on the concentration of the solute. Well, right now, we're not actually looking to see how high it goes. They're just looking for a trend. What would likely happen? I would say boiling point will rise. Now, the reason that happens, because what happens in water when it boils is these little molecules get agitated and they start bumping into each other. And some of them bump right out of solution, right? They become vapor. Well, what happens when they're surrounding these molecules? Well, we have all these oxygens that are pointed this way towards this positive sodium. And then we have all the hydrogens pointed this way towards this chlorine, because hydrogens are slightly positive. So if this water molecule is trying to bounce out, it's already involved with this chlorine atom. It's already kind of situated, so it's not going to bounce against these other water atoms, and it's not going to bounce out as easy. So the boiling point goes up. Eventually, you'll add enough energy to where they'll snap off of this sodium and off of this chlorine, but that's why boiling point rises. So the colligative property is boiling point goes up, right? Boiling point elevation is the colligative property. And this is why. When they're not involved with any attractive force with these sodium and chlorines, then they can bounce right out. Otherwise, they cannot. And same question here. Vapor pressure is measured in units of atmospheres, ATMs. So what would most likely happen to the vapor pressure if 25 grams of salt was added to a closed container? All this is just filler information. All I need to know is that this is the pressure, and I'm adding 25 grams of salt. And what's the colligative property for vapor pressure? Vapor pressure goes down. That's the colligative property. When I add 15 grams of anything, or 25 grams of anything, 25 grams of salt, dirt, or whatever, vapor pressure goes down. Why this happens is the same reason that this happens. The water can't get out. If I have water in a pan, and these are all molecules, then they can escape freely, right? They can vapor pressure right out. Well, if I have a pan of water, and I've added a solute, so I'm going to represent solute with these darkened bubbles. Can as much water pressure get out, vapor pressure get out? No, only these guys can get out, so it's less vapor pressure. Here we have all this stuff that can get out. Here we only have these that can get out and create a pressure, right? Okay, so vapor pressure goes down, and that's why this happens. A term that is used to describe two liquids that are soluble, miscible, right? I always think of mixable. If two liquids solvate each other, then it's a miscible, mixable. Sounds very similar. 4 colligative properties that are affected by solute. Well, we discussed this in class, right? I only want you to know 3. Vapor, pressure, depression. And what I mean by depression is that it goes down. Boiling point elevation. That goes up. And freezing point depression goes down. The 4th one, if you're curious, is osmotic pressure. And it goes up. Which 2 colligative properties decrease? Well, it's the 2 with the down arrows. So it's vapor pressure and freezing point, comma, freezing point. Sorry, my writing's so messy. Usually I don't have a camera in the way right here. Which 2 colligative properties increase? Well, which one goes up? Boiling point. And really, that's all I want you to know. Boiling point goes up. Okay. What types of compounds form electrolytes? Ionic compounds. Why? Because they break down. NaCl, they break down into their ions. When it goes into solution, it becomes Na plus Cl minus, right? That's why it forms an electrolyte. That's why it will conduct electricity, because you have all these positively and negatively charged ions in your solution, and the electricity can just flow right through. Which of the below best explains what happens when salt dissolves in water? Well, I just showed you. And we drew this picture up here of water surrounding the positive and negative. So let's look at this. Polar solvent molecules surround only the positive ions. Well, that's a lie because they surround the negative ions. So that's not it. Polar solvent molecules surround the positive sodium ions and the negative chloride ions. So I like that one. So we're going to mark him. Solute and solvent molecules form a crystalline structure. That makes no sense, so that's not it. Solute and solvent particles do not interact. Well, that's a load of hooey. We know that they interact, so that doesn't make sense. So B is our answer. Okay. How many grams of sodium nitrate are in 5 liters of 3.5 molar sodium nitrate solution? Okay, so what we have here is we have a molarity problem. We have a molarity, so 3.5 molar equals, we don't have moles anywhere, so we're going to say X moles, and we have 5 liters. So 5 times 3.5 equals 17.5 moles, right? So now we have moles, but they're not asking for moles. They're asking for how many grams. And really, the biggest thing that I can impart to you about this test is you have to read the question. What are we looking for? So let's set up a dimensional analysis. 17 moles NaNO3. And down here, we're going to have 1 mole NaNO3 because the rules still apply for dimensional analysis. These units have to cancel. And then we have grams of NaNO3. And how many grams are in 1 mole? Well, I don't have my periodic table, so let's grab that really quick. Okay, so we have a sodium that weighs 23, plus we have 1 nitrogen that weighs 14, plus 14, plus we have 3 oxygens, so 3 times 16, enter, so we have 85 grams. So what we need to do is multiply 85 times 17.5 times 17.5 equals 1,487.5 grams NaNO3, and that is our answer. How many grams of NaNO3 make up the solution? And we will continue in the next video.